Okay, we are on to transformations in both 6 and 7. Yay, transformations, I always like. So we always start the same way. We start with our parent function. My parent function here is the square root of x. And that's always my first table that I make. Now remember, I can't plug in negative values for the square root of x, so I just start with 0, 1, and then I think of other perfect square roots, so 4 and 9. And so when I plug that in, I get 0, 1, 2, and 3. So first step always is your parent function. And then is to look at the transformations. My negative. So my negative, is that on the inside or the outside of the function? Well, it's outside the square root, and so when it's on the outside, it's a change to the y values. Okay, then the minus 3. See how the minus 3 is inside the square root? When it's inside the function, it's a change to the x. And then the plus 1, well, the plus 1 is no longer inside the square root, so that's going to be an actual change to the y values. So our second table comes in to play where we actually apply our transformations. Remember, when it's a change to the x, like the negative 3 is, we do the opposite operation. So if we're subtracting 3, my x values, we're going to add 3. So to all of my x values, 0, 1, 4, and 9, we are going to add 3 to every single one. Okay, now my y values, I have 2 transformations, so I'm going to write them both on the table. So the negative, remember when it's a change to the y, it's the same operation. So it's being multiplied by a negative 1, so we're going to multiply y's by a negative 1, and then it's being added by 1, so we're going to add 1 to our y values. So 0, 1, 2, and 3 are all going to get multiplied by the negative 1, and then we're going to add by 1. Now, some questions have come up, like what do we do first? Well, it's the same as what we would normally do with PEMDAS. We would first, now, like for this, we'd first multiply by the negative, because you multiplied first, and then you would add by the 1. So my x values become 3, 4, 7, and 12, and my y values, well, negative 0 plus 1 is 1, negative 1 plus 1 is 0, negative 2 plus 1 is negative 1, and negative 3 plus 1 is negative 2. So this is my transformed function. This is the table for negative rad x minus 3 plus 1. So we're going to plot those points. 3, 1, 4, 0, 7, negative 1, and 12, which is way off of it, negative 2, looks like that. So it still looks like our parent function, but it's transformed. So there are 3 transformations. We have to describe those transformations. First one was the negative. So the negative, we know anytime there's a negative, it causes a reflection. We just have to think about what did it reflect over. And in this case, if we look at the graph, now the normal like parent function looks like this. So it looks like this. So we know that, okay, it must have been reflected over the x-axis, which it was. Oops, that's my wrong pen. Now, when we're doing this, like another way, is a change to the y is always a reflection over the x-axis. If it was a change to the x, it would be a reflection to the over the y-axis. Okay, so then the minus 3. The minus 3, remember it's kind of the opposite of what you would think. It actually moves it in the positive direction. It moves it to the right. So the negative 3 moved the graph 3 units to the right. And then the plus 1. Remember, change in y kind of moves it up or down. So the plus 1 moved the graph up 1 unit. And that is our descriptions. So then my domain, now remember, my domain, we're looking at the blue one, not the orange one. My domain is from left to right. So left, it starts at 3, and then it goes on to infinity. So my domain here would be 3 with a bracket to infinity. Bracket because it's a solid point, and it continues on. My range, now my range is from bottom to top. So from bottom, it's really going down forever. So my bottom is negative infinity. And my top, well, it ends at positive 1. See, it ends right there. So negative infinity to 1. My x-intercept, so my x-intercept is where it crosses the x-axis. So that looks like it's here at 4, 0, which was one of our points that we plotted. And then my y-intercept, well, it actually is never going to cross the y-axis. So if you see, like, this is our starting point, it continues on. So there is actually none, or NA, or whatever you want to put. So that does it for 6. Okay, so now on to 7. Pretty similar, right? It's just, a little bit different transformations here. So we start the same, my parent function. My parent function here is x squared. And so we start with that table. Now this is one of our more normal ones, right? We can plug in any x value and get a y. So negative 2 squared is 4, 1 squared is 1, 0, 1, and 4. So we again have 3 transformations. We have this 2. The 2 is on the outside. It's not being squared. So it's on the outside, so it's a change to the y. The minus 1, well, the minus 1 is within the square. So this minus 1 is a change to the x. And then the plus 3, since the plus 3 is on the outside, it's a change to the y. So we're going to put that into our table. Remember, a change to the x is always the opposite operation. So because it's subtracting by 1, we're going to add 1 to all of my x values. So my original parent function x values are going to get all increased by 1. Okay, now my y. There's 2 changes to the y. So this 2 is being multiplied by y. So we're going to multiply all of our y values first by 2, because we do the same operation. And then we will add 3. So all of my y values, 4, 1, 0, 1, and 4. We all start that way by multiplying by 2. And then adding by 3. So when we do the math here, negative 2 plus 1 is negative 1, 0, 1, 2, and 3. Now my y values, remember, we multiply first, so 2 times 4 is 8, and then 8 plus 3 gets me 11. And then 2 times 1 is 2, plus 3 is 5. And then 2 times 0 is 0, plus 3 is 3. 2 times 1 is 2, plus 3, 5 again, and then 8 plus 3 is 11. So that's my table for my transformed function. So I'm going to graph that. Negative 1 is at 11. It's 11 here. 0 is at 5. 1 is at 3. 2 is at 5. And then 3 back up at 11. So my parabola looks like that. Okay, so now we need to describe our transformations. We have 2, the negative 1, and the 3. Remember, whenever y is being multiplied by a number that's greater than 1 or negative 1, because the negative always causes a reflection, that causes, the 2 causes either a stretch or compression. So when it's bigger than 1, so 2, 3, 4, causes a stretch, whereas a compression would be like 1/2, 1/3, 1/4. So the 2 caused a stretch. The -1, remember, x is a left or right, and so it moves it 1 in the right direction. One unit. And then the +3, remember, y moves it up or down. So the +3 moved the graph up. Three units. Okay, now my domain. My domain, it's a polynomial, you know, and we can look at the graph. It goes from arrow to arrow. My domain is all real numbers. Okay, and then my range, bottom to top. So from bottom, the lowest point is at 3, and then it continues on forever and ever and ever. So my range is 3 to infinity. Now one thing I'll say, like kind of circling back to this one's a polynomial, so it's all real numbers. 6 is a radical function, and so we took what's inside the square root, x minus 3, and set it greater than or equal to 0. And we get x is greater than or equal to 3, which is what we wrote down as our domain. So, kind of a side note, another way you can think about it too. Okay, so then our x-intercept. Well, if you notice, it doesn't cross the x-axis at all, and it won't. Like, it's not all of a sudden going to start coming down. So there is no x-intercept. And then my y-intercept is where it crosses the y-axis, which was at 0, 5. And that is that for 7. So transformations are done. Let's actually just keep going through. Let's go to piecewise. We're almost done. Okay, so with number 8, the piecewise functions, you know, it's all it is really just looking at your tables. So we're going to start with negative 3x minus 1. Remember, it's giving us your domain here. It's giving us what x values we can plug in to negative 3x minus 1. So we have to use negative 4. That has to be one of our values. Same with 0. We have to have the endpoints, because just like you would if you were to graph this as like on a number line, negative 4, you would graph it at negative 4 with a closed circle, and 0, you would graph it with an open circle coming together. And so that's why we have to use negative 4 and 0. There are endpoints. So negative 4, because it's or equal to, it's a closed circle, and because 0 is just like x is less than 0, it's an open circle. Now I can pick any value in between. I can pick negative 2, negative 1, negative 3. I'm just going to pick negative 1. Okay, so negative 4, we plug that in. That gets me 12 minus 1, so 11. Negative 1 I plug in, I get 3 minus 1, 2. And then negative 3 times 0 is 0 minus 1, minus 1. So I'm going to graph just that portion for right now. 0 is at negative 1 with an open circle. Negative 1 is at 2. And then negative 4 is off the graph. So 9, 10, 11. Where is that? Here. And it's a closed circle. So we are going to connect those points. I don't know where my ruler is, so I'm just going to use a Post-it. Okay. And so just like on the number line, it's a segment on our graph too. Okay, so that does it for the first function. Our second function is 1 when x is equal to 0. So it's actually only telling us one x value, and it's giving us our y value is always 1. So our x value is 0, closed circle because it's equal to, and our y value is 1. So that's going to be our point 0, 1, is a closed circle there. And that's it for that one. Okay, now this one, the square root. Now, with this one, my x values are greater than 0. We still have to put 0 in there. We can't ignore 0 because it's our endpoint with an open circle. Then we can put any other values. I can put 1, but I know 1 plus 1 is going to get me rad 2. It's going to get me a decimal. I can put 2, but that's going to get me 3. So I'm actually going to put 3 in, and I'm going to put 8 in. Now, okay, so the square root 0 plus 1, the square root of 1 is 1. 3 plus 1 is 4, so the square root of 4 is 2. And then 8 plus 1 is 9, the square root of 9 is 3. If you wanted to pick other values and get the decimal, that's fine too. So 0 is at 1. Now it's an open circle. When it's on top of a closed circle, you just, it's closed. So that's why we use, sometimes it's nice for me to be able to see that, because then I know you know what you're doing. Okay, then 3 is at 2, and 8 is at 3. Okay, yeah. So we know what a square root function looks like, so it's like my parent function, and there it is. We also know too, like from transformations, this plus 1, it's inside the square root, and it actually moved my function to the left one. And so if we would have like had the entire graph, it would have started here and then gone up, but it's just the portion. Okay, so my domain. A few ways that you guys can think about it. You can think about it looking at the graph. So, left to right. Farthest point is -4 to infinity, which that's my... another way is you can look at like the domains here and graph them all on one number line to maybe like help you to visualize it a little bit better. So that would be -4 to 0. So -4 is a closed circle. 0 is an open circle coming in between. Now to graph x is equal to 0, it's just a closed circle. And then greater than 0 is greater than 0. So it basically goes from -4 on, which is our graph too. Okay, so then the range. The range is from bottom to top. The lowest it goes is at -1. Now because it starts at an open circle, it's going to be a parentheses. Now, it's weird, but because the green picks up, and the green is actually going up and up and up forever and ever and ever and ever, even though the pink stopped, the green is actually going to pick up, and it's -1 to infinity. Like if we were to like expand this graph out, the square root continues to go up and up and up and up forever and ever and ever. That's why it goes to infinity. Okay, let's look at 9. We're so close, almost there. So we're going to start the same way, looking at our different t-tables. So start with 2x minus 1 if x is less than -3. So we have to make sure we put -3 in. It's my endpoint of my domain. So -3 always. And then any other x values that are less than that. So I can put -4, -5, -6, -7, whatever you want. Because it's less than, it's an open circle, not or equal to, right? So this would get me -6 minus 1 is -7. -8 minus 1 is -9. -5, -10 minus 1 is -11. So we can graph that. -3, -7, open circle. -4 goes off the graph. -5 is definitely going to go off the graph. So it's a continual down. Oh, that was a really bad line. So it's a line down, going down at that point. Okay, now let's do x squared. So that's giving us a range of values. So we have to use those. We have to use -3 and we have to use 1. If you want to put more in between, you can. I usually only put 1 in between. And so we graph from that. So -3 is a closed circle and 1 is an open circle. So -3 squared is 9, 0 squared is 0, and 1 squared is 1. Now, you should also know from our parent functions, it's a quadratic. So you already know the graph of that one. You just have to know its domain and the restrictions there. So -3 is at 9 with a closed circle. 0 is at 0, and 1 is at 1 with an open circle. If you want to put the points in between, you know this is going to be -1, 1 and -2, 4, because we know our parent function so well. You can, because it kind of can help you to draw that parabola. And that's that. Okay, so then our next and last one is -4 when x is greater than 1, or greater than or equal to, sorry. So if it's greater than or equal to 1, we need to use 1. It's going to be a closed circle, and then any other values. That's a closed one. Okay. So remember, when it just gives you the number, it's saying that's the number no matter what. You don't have to plug in anything, so it's just -4 the whole time. So 1 is at -4. Well, this is going to be a fun range 1. 2 is going to be at -4, and so on and so on. It is a horizontal line going on forever. Okay, so that's your graph domain. You know, I prefer just to look at the graph. It's -infinity to infinity. If you wanted to, again, kind of do what we did up there with like the number line, you can. So -3, x has to be less than -3, so open circle, going down. From -3 to 1, -3 it's closed there, and then 1 it's open, so in between those values. That's a 1, small 1. And then greater than or equal to 1, so closed at 1 and greater than. So it's going in opposite directions forever, so that's how we get the all real numbers. Now the range. The range, bottom to top. Okay, so the pink one starts. It's going on forever in the negative direction, so it's -infinity. It ends, the pink one ends at -7. It's an open circle, so it's parentheses. There's nothing going on in between here to -4. So we're going to pick it back up at -4. Now, because it's just this horizontal line there, that's it. But then there's more function. So we keep going, there's a gap, 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 up until 0 it starts again. Now it's a closed circle at 0 because it's a solid line, so it's a bracket. And then as we go up, well, it stops. The highest point is at 9 with, again, a bracket. Sorry, I ran out of room there because it's a closed circle. Now again, you can do like the shading that you might have talked about in your class. But so like from here, it's going -infinity because we hit an arrow, and then function, 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 and then it stops with an open circle at -7. And then nothing, 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 and then it hits -4. Just by itself, that's one solid line at -4. Nothing, 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 and then it hits at 0. It's a solid line at 0, so it's lower than here. And so picks up, there's stuff, and then it ends up here at 9. That's my highest point. It's a solid line, or it's a solid filled in point, so it's the bracket there. Okay, we are so close. Okay, so 10. What equation would result in the graph of f of x is equal to x cubed being reflected over the y-axis and shifted down 5 units? So if it's reflected over the y-axis, that's going to be a change to the x. Which means it's inside the function. and then shifted down 5 units. Down is a change to the y, which means it's outside. So when it's inside the function, now our parent function is x cubed. When it's inside the function, that means it's within the parentheses. It's within what's being cubed. And a reflection is always that negative. So it'd be negative x cubed. And then a change to the y is outside. And remember, it's the same operation. So down is minus 5. And that would be your transformed function. Last one. Hallelujah. So number 11, what equation would result in the graph of f of x is equal to the square root of x, so our parent function being reflected over the x-axis, shifted up 3 units, and shifted left 1 unit. So reflected over the x-axis is a change to the y. So that means it's outside, because change to a y is outside, so it's going to be outside the square root. Up 3 units, remember up is a change to the y also, just like it was up above. And that's going to be, again, outside the function, or outside, in this case, the square root. Now left or right is a change to the x. Left, change to x. Change to an x is always inside the function, so it's going to be inside the square root. So my parent function here, I'm just going to write it down here below. So the reflection is a negative, and because it's outside, we're going to put it outside the square root symbol. And then the left 1 is a change to the x. It's inside, whoa, my pens are getting wild. It's inside the square root. When it's left, that moves it like in the negative direction. Remember, x is always the opposite operation. So that would be a plus 1. And then up 3 units would be outside the square root, so plus 3. Make sure if you're doing it, you make sure it's outside of the square root, not under it. And that does it for chapter 3. Heck yes. Okay, well, have a good weekend. See you guys later. Have a good day. I don't know what time it is and this time that you're watching it, but have a great day.